So here's a really quick explanation about parallel lines. Parallel lines are lines that never cross each other. That's the definition of parallel. That will mean that they all have the same gradient. So here are four lines. In fact, all of these four lines have exactly the same gradient, even though on the outset and when you look at them they may not appear to. So here's the first one. Remembering we've got the equation y equals mx plus b. M is our gradient, so we're looking for equations that have this value the same. So here's y equals 2x plus 7, this has gradient 2. Y equals 3 plus 2x also has gradient 2. These last two are not in this standard form, so we might need to do a little bit of rearranging, and you can either do that by paper or in your head to see if they've got the same gradient. So let's do a little bit of rearranging here. We'll see that this will be y equals minus 12 plus 2x. Awesome. Has the same gradient of plus 2. And this one here is a fraction. 4x over 2, 7 over 2, 2x. Again, same gradient. So we can see that these four, whilst they all look different, are all parallel lines. The thing that's different between them all is the y-intercept. It just means how far up or down these lines have been translated. Imagine a Cartesian plane. Here's one line. The other one will be parallel. You might have another one. So these y-intercepts are all different, but the gradients are all the same. Y-intercept of 7, 3, minus 12, and 3.5. So let's have a quick example about what sort of questions you might get asked about parallel lines. This question is asking us to find an equation of the line parallel to y equals 4x plus 3, but we want it passing through this point, so keywords are parallel to this equation and through the point minus 1, 7. So we want a parallel to this equation means we need the gradient to be the same. So we know that for our new line, our m is going to be 4, and I want it to pass through this point. What this means is I'm going to use my point gradient formula that we learnt last week. Substitute in the values that I know. x1 and y1 is this point here, x1, y1. Here is my gradient m. I'll substitute all those values in. M is 4, x1 is minus 1, y1 is 7. Tidy up the algebra. You can do this by hand or using your CAS. 7 over here, 11. So here is a line. It's parallel to this. We see that this was 4x plus 3. We've got the nice 4x, so we can see that it's parallel. Passes through the point minus 1, 7. When x is minus 1, I get 11 minus 4, which is 7, so it does pass